So Unit 2 is an introduction, or is a unit on functions and equations. So we're going to look at Unit 2, Lesson 1, which is an introduction to the idea of a function. So please excuse my noisy nose. I have a bit of a cold. So let's have a look. What we're going to do, I'm going to go through the tasks in the lesson. So if you have the lesson open in front of you, you can follow what I'm saying. So I'm going to look really quickly at task 1. And it talks about the definition of a function and the notation. And one of the examples it gives you is f of x equals 3x plus 7. So let me explain what this is saying. So firstly, the letter f is the name of the function. It's like we're naming the function f. Okay, and the letters we typically use are f, g, and h, but we use other ones as well. In the parentheses then you have x, which is the input. So it's what we put into the function. And then what we have over here is what we call the function's definition, or its rule. So basically what you have the function f. You put in x, your input, then you do 3 times x, so 3 times your input, plus 7, and that gives you an output. Okay? So a function has 3 parts, basically. It has an input, which is your x. It has a process, which is 3x plus 7, and that gives you your result, which is your output. Okay? So if you look there in the example, there's a couple of other ones. There's a couple of examples of other ones. One of the important ones there is this one that you'll see. A of r equals pi r squared. And in this case, what this means, the function is a, which is the area function. Your input is r, which is radius. Your process is pi r squared. And what does that actually give you then? It gives you the area of a circle. That function is the area of a circle formula. Okay? So it's telling you area is by putting in the radius into pi r squared, gives you out the area of a circle. Okay, so think of that in terms of function notation. Generally what we have as well, we would have something like sometimes you will see it that you have, instead of f of x, you'll have y equals 3x minus 7. Okay, when it's written like this, y equals, that's not function notation. Function notation is the f of x, or the a of r. It's basically where you have a letter and your parentheses after it with your input in it. That's function notation. So the first two are, this one here is not function notation. It doesn't mean it's not a function. It's just not written in function notation. Okay? So let's get on to task 2 quickly. Task 2, it looks at evaluating functions from the definition. Okay? If you read it, function notation is a more concise when evaluating. Okay, so it's a more concise way of evaluating a function. So I'll show you what I mean by that. So if you're given y equals 18 minus 2x, and you see it says find the value of y when x equals 4. Okay? In that case, what you do, you substitute in 4 for x, and it gives you a value for y. So you would have then y equals 18 minus 8, which equals 10. Right? But when it's written f of x, so you see part B, f of x equals 18 minus 2x, find f of 4. That means that 4 is your input, so you do 18, replace all your x's with the input, so it's 18 minus 8, which equals 10. So look, when you write it like that, what you actually get, when you're writing the equation, look, there's your input, there's your output. Okay? So when you write it in function notation, your input is clear, and your output then, you see how that corresponds to it. And it asks you, look, to write your answer as a pair of coordinates. Well, it's basically an x and a y. Your 4 is your input, is your x, and your 10 is an output, is your y. Okay? And it asks the question, which is more convenient and why? Well, I think it's more convenient to write it in function notation because you can see what you're putting in for x in the way that it's written here. Okay? And it's just clearer, it's more tidy notation, that's all really. And which variable is independent and which is dependent? Well, if you look at it, the y coordinate, which is the 10, came out because of the x that was put in. So we put in an x and that gave us a y, which means the y depends on the x. So the x is independent and the y is dependent. So there's a couple of little practice examples for us to look at then there. You'll see practice and it has A to F. So let's have a look at a couple of them. So first A, B. Right, I'm going to do B really quickly. So I'm going to do two of them. I'm going to leave the rest of them for you to do yourself. So you're told that f of x equals 30. F of x equals the absolute value of 30 minus 3x squared. Okay, so you're asked for f of minus 3. Okay, so f of minus 3. What does that mean? It means we go back to the original definition. This definition here. We just pull out any x's and replace them with minus 3's in parentheses. So we're going to get f of minus 3 equals 30 minus 3 times minus 3 squared in parentheses like that. And that gives you 30, the absolute value of 30. Okay, so minus 3 squared is 9. 9 times minus 3 is minus 27, so 30 minus 27. So that gives you the absolute value of 30 minus 27, the absolute value of 3, which is 3. Alright? Pretty straightforward. And now let's have a look at one more. I'm going to look at f. So f tells us f of x equals 4x squared minus 3. Okay, 4x squared, it doesn't look like an x squared. Hold on till I fix that. Okay. Alright, now watch this. This is something that happens quite frequently. It asks you to find f of n plus 3. What does that mean? What that means is that we're going to take out the n, or the x, and replace it with n plus 3 in parentheses. So 4 times n plus 3 squared minus 3. Okay? Now, you may need to simplify that out. So I'm going to put down that that's 4, n plus 3 squared. If you expand that, we should know by our binomial theorem it's n squared plus 6n plus 9 minus 3. And just tidy that up a small bit. And that's going to give you 4n squared plus 24n plus 36 and then minus 3. It's going to give you plus 33. Alright? So basically when you were finding f of n plus 3, you took out the x in the definition, you replaced it with n plus 3's. Simple as that. Okay, let's move on. So task 3. So I'm going to explain really quickly how this works. It's basically you're evaluating the function from its graph. You're given the graph of a function, you have to find f of a certain value from the graph. So say for example you have something like this. Now I'm not going to spend too much time on this. So if you have a graph that looks like that. So if I say to you to find f of 2, well, that means your input, your x is 2, so you want to go where x is 2, so say x is 2 here. And what you do is you go vertically until you meet the function. So that would be that way. If you go vertically upwards, there's nothing above, so you're not going to hit the function, but it's down below. And what you do is you find the y value that matches that. So when f is 2, your y value is this value here, which in this example looks like maybe it's what? Maybe 1 minus 1. Okay? By the same token, if I ask you to find f of minus 1, what would you do? Go back to minus 1 on the x-axis, go to where it meets the function, which is there, and you'll see that it's, what's the y coordinate at that point? No, I don't know. We'd have to, in a graph it would be better drawn and clearer, so in that case I would say it's probably 2. We'll go with 2. Alternatively, the question you could be asked is this. You could be told that f of x equals 0. So find the value of x. So that means your input gives an output of 0. So that means your y is 0. Okay, your output is 0. Your y, what's your input? So look, your y is 0 here, and your y is 0 here. Your y is 0 here. So there's 3 possible values. Okay, so we could look at the first one on the far left there. We could say that that's what? Say minus 3. We could look at the second one, and we could say that that's 1. And we could look at the third one and say that it's 6. Now I'm just giving rough estimates of the values and just trying to explain roughly how it's done, but that's how it works. Okay? Right, last piece. So we're going to look at domain and range here. So when we talk about, this is task 4. So domain is all inputs. Well, I'll write that again. All possible x values. And range is all possible y values for any function. So let's have a look at a couple of values, or a couple of examples, and see what we mean by that. So let's look at A. A is a simple one. F of x equals 3x plus 1. If you look at that function there, is there any value of x, any input, that won't work? You can put any number you want there and it will give you an output, right? So that means that the domain is all real numbers from minus infinity to infinity. Okay? So we say minus infinity that I've written first tells you where it starts, the infinity tells you where it stops, and the round brackets, I'll explain that in a little bit. And then the range, look, you can get any possible value you want as well. By choosing the appropriate x, you can get whatever y you want. So that means that the range is minus infinity to infinity. Now let's look at a couple where there's a difference in what comes up. Look at f of x equals x squared, that's b. So that function is the squaring function. You can square anything. You can square negative numbers, you can square 0, you can square fractions, you can square rationals, you can do it, you can square anything. So the domain is minus infinity to infinity. But if you look at this now, what's the range of that function? Well, when you square something, you always get positive outcomes. The smallest value you can get is 0. If you square 0, you get 0. Okay, when you square negatives, you get positives, so you can never have a positive, or you can never have a negative outcome to a squaring function, which means you can never have a negative output. So it's from 0 to infinity is the range. And the round bracket means, sorry, that bracket should be square bracket. The square bracket means that it includes 0, from 0 to infinity, including 0. If it was a round bracket, it would mean that we're not including it. Okay? Now let's have a look really quickly at a couple more. C. Right, I'm going to write this one out because this one is going to cause a bit of difficulty. So it's f of x equals x squared minus 5. Now look, again, you can square anything, which means you can put anything in. Okay? You'll square it, you get some value, and you subtract 5. So that means there's nothing there that we can't put in. Everything can be put in. So when you're thinking of domain, you have to think, is there anything that won't work with this function? So the domain here, I'm going to say, it starts from negative infinity, goes to infinity. It can be anything. But the range, right? When you square something, the lowest value you can get is 0. If you square 0, you get a 0. Squaring any other number, positive or negative, gives you a bigger positive value. So, but you're going to be subtracting 5 as well, which means that actually this function starts at negative 5. And it goes all the way to infinity. Alright? Because you think the smallest value you can get is when x is 0. X is 0 squared gives us 0 minus 5, minus 5. Okay? And we'll have a look at one more. We're going to have a look at, let me see, we'll have a look at 5. Number 5. F of x equals the square root of x minus 2. Okay, here we go. Square root, what do you know about square root? Is that going to place any restrictions? Yes, you cannot take the square root of a negative number. So your inputs can't be negative. Okay? Your inputs can't be negative. So look, x minus 2 here, what's inside the square root? If we have a negative in there, it can't work. So x minus 2 has to be positive. Okay? So what values of x can go in? If x minus 2 has to be positive, or x minus 2 has to be 0 or bigger, that means x has to be 2. 2 to infinity. Alright? We just want what's inside the square root to be positive. 0 or bigger. And lastly, I'm just going to look at number 4 really quickly, right? So this one is what we call a rational function. And in rationals, what you're looking out for is, you're looking out for values of x that will give you a 0 on the bottom. So if you look at number 4, f of x equals 1 over x squared, in that one, your x cannot be 0, or whatever is under the bottom, in the bottom of the fraction, can't be 0. If a value of x is going to give you a 0 on the bottom, it means that the function itself, that value can't be in the domain of the function. Okay? So, that's that.